Yeah, this test doesn't work. It thinks that this cubic is diverting too much from this fourth degree polynomial. And I think it doesn't because, well, it kind of starts off the same way. I mean, nah. I mean, the only way that this is true is when we skip a minimum, so then this point should be, let's say this should be something like this in between here. So this holds, and then we must have a minimum all the way up here, maybe, and then have a maximum, and then still have a fit here. Which in my eyes means that if there is a minimum that we skip, then that minimum is definitely higher than this one. There's no other way. There's no way that this is going, in reality, that this is going down like this, and then, I don't know, has a minimum all the way down here, lower than this point, and then go up again, and then go down again, and then we skipped over this minimum. That looks really weird. I wouldn't know how that would work. Theoretically it's possible, I guess. Anyway, I was going to commit what I made. Quit, yes. I can use that. We're not done with the test, I guess. I don't know. The diff just gets too big. I'm gonna commit it. Yeah, what shall I say about it? The whole program wasn't very much a success, I have to say. No, I could print, yeah, let's say Guess you can print if the green one is deviating too much from the red one or not. No, sorry, the red one's a cubic as well. From this, from the black one. I mean, this green thing deviates too much from this purple one, black one, whatever. Yes, but this doesn't, obviously. And this doesn't. All of these don't. So when do they? Only when this minimum here of the green one is like way past that point. If that's the real thing. Yeah, that's also not true. I don't know if you can use this. I'll just save it, I guess. What about these things? I don't need to keep that. Verify, what is that? It's hardly anything. Oh yeah, that can definitely be removed. The RMS, maybe I want to keep that one. Let's see. Nah. Not super interesting. I won't add it to the Git anyway. Commit. Yeah, VIP. It's always VIP. Okay, I think that what I'm going to do is add a new state to this the state machine, basically. At the moment that we jump to an extreme, now you would say that means that we literally call I don't know which file it is. Something with jump. So extreme jump. Okay, I think it's stored here. There's an extreme jump. Now this is more the one that I wanted actually. So we jump to a local extreme of the 4th degree approximation. Then I want to change states to something that I'll call backtracking or whatever. So temporarily we use a different algorithm. I think that might clarify the structure of the code a bit. The question is, however, am I always calling this function? I suppose I am. These are all the possible ways to change W. See where this is called from, and then the others are probably called handle underscore something. It's also an extreme jump. There are also other member functions, I think, that call these handle things. Nou ja, okay. So here it is called, and here, and here. Wow, wow, why so many? At least this is in and the local extreme, so that makes sense. It's all in this file. This is just the declaration, a friend declaration, and the definition and debug output. It's all in this file. So the handle local extreme jump does call it. Whoa, wait. Handle local extreme jump. Oh, okay. Yeah, that's what I mean. So it's called, it's just a comment. Haha. No, this is not a comment. It is also called from here, which is this is really a handle local extreme. So at the moment that the local extreme is being found, and we do a fourth degree, we make a fourth degree polynomial fit for approximation. This function is so big. There we are, handle local extreme. Yeah. So it's called there, click case 2b, and that is below the point where the fourth degree polynomial is being fitted, which happens here. There's another one here. No, it's just another case, so okay. Just jump around. Yeah, so it's 87%. Now we go to the top, 53%. So this one is from another function, but I guess that then this function is only called from the function below. Oh, not. It's also called from here. It is called from here though. So it's called from here or from here, where this one is handle local extreme jump. It's a recursive call, what? Okay. Abort H direction, great. Okay, that's called from everywhere. Nou ja, I mean, I'm exaggerating, but the entry point is definitely not really the thing that I want to intercept. It's more the fact that we did make a fourth degree fit. So that gives us a derivative, long division, 16 cubic set H nodes array. We get up till 2 roots of the quotient. So if there's nothing to jump to, then we just call handle loss extreme plus step. Okay, I do not want to switch to the new state, the backtracking state in this case. Both roots on the same side as the found extreme. The root closest to the extreme. That's the correct type. So again, we need to do a step in the direction of H direction. So this is just a step. So for this case, I do also not want to switch to that new state. So there are different cases, and it's exactly the case. It is the case though, but only in this part of the code, where the handle fourth degree approximation jump is being called, that I want to switch to that other state. So we need to jump to the relevant root. That means the root of the quotient, which means the root of the derivative long division by the local extreme that we already found. It's a long sentence, but that just means we jump to the another local extreme of the fourth degree approximation. And that happens here. And then I want to switch to that other state. Okay, so maybe we can do state is something. Now, here I have other cases. Case 3. You need to jump to the lowest root and set opposite direction to the other root. Best root is that. Okay, so that would also be a case where I want to change the state. Case 4, need to jump to the root that is on the correct side. Yeah, indeed. In both cases, we do this handle fourth degree approximation jump. So I could change the state here as well. Now here I set state to find extreme, but that would be for the other cases then. Maybe it probably should already be this state. I'm having the feeling that. True and false. Return true, a lot of returns. Oh, right, yeah, okay. State can be, I think, one of two things. Either extra sample or the next extreme, or find next extreme, whatever you set it back to here. To this one. And if it equals that, we execute this block. Or it's just to assert. Else it is already set to that value, I think. So I can skip this one. But then we come here and then state is one of them. One or the other. Now you might return. I'm looking for a return which should be highlighted. Yep, here. So it's not clear what the state is at the moment that we return here. Actually, it should be set to get extra sample. Yeah, I'm not sure. I think I'll just set the state back already here then. So after we fitted the thing. Line 1832. So can remove it here. And then before this line. And then probably before this whole block. So before this block, okay, here would be good enough. Just put it here. No, it's hardly default. It's really one or the other. Maybe I should set them explicitly. Because it's kind of weird to do say set the state and then if A set the state to something else do nothing. Because the state was already set. It just doesn't make much sense. So whatever the state is, we just have to set the state to one or the other. So in this case, I'm not setting, this is case 1. So here I want to, continue with this. Continue finding the next extreme, or something simple like that. And then case 2, no, same thing here. So we're not setting the state to ... Therefore we have to set it to that. Or we set it to dot dot dot. And then here, in this block is always set to dot dot dot. So I think now just it's always set. Yep. So that should work. Now let's make up a new state number. So iteration state enum I have in find extreme, an extra sample kind of belongs to that. Sometimes you don't have enough samples to. No, that's not true. Sorry. Normally it finds the next extreme. And then once we find the extreme, we might not have enough samples to fit a fourth degree polynomial, and then temporarily it's set to this one. And I'll add one here though, which we'll just call backtracking. So we're going to set the state to backtracking in the dot 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 case here. Iteration state backtracking. I think I had only two of them. I think, yeah, well, this should compile now, of course, or maybe not. No, I definitely have to add this. Now it should compile. Compile. But hopefully it will assert somewhere, because I'm switching to an unknown state, like literally. And this project has quite a few asserts. 510 asserts. That's not little. Yeah, one of them is going to catch this. I'm pretty sure about that. So first we're going to find, oh, that was already it. It finds the minimum outside of the window here. So, building. Yeah. Yes. Implement this state. Now I'll just do it in order. So we get here case iteration state backtracking. Now we do this correctly, and then I can remove all the backtracking code that I added to the other case, because I want to move it over here. Now the other case is this one. Find extreme. But. The annoying thing is that it kind of starts with stuff that I have to do anyway, I think. Or not. No, maybe not. Well, I think Okay, so we have a new sample and it is inserted in the chain. So some cubic was broken up in two cubic fits. And then the two new cubics, or left and right of the new sample, are called, left and right cubic. And left and right node. The node then points to the leftmost node of the cubic. And I think what I want to do, there is some logic here implemented, algorithm, and in some cases that algorithm would fail. So I want to have during the backtracking, we just try to filter out situations where this algorithm would fail. And then we'll do something else. But if we find that this algorithm will not fail, then I'm not going to duplicate it, and I'm just going to use this algorithm, obviously, right? So maybe I should put the backtracking above this case, put it here, and then we can just fall through. In the case that it is okay. Which means that rather I should put this one above it, so I can use a fall through. And that is, I before I do that, I think I have a way to just jump back to the beginning, maybe. So this is the switch. This is an else, but we do have this for loop. So I could do a continue, and then we just continue here. And our master board is still false, of course. Otherwise, we would never have gotten here in the first place. So I can just do continue, and then we all start at the top here. So I can just change state and then do continue. This maybe better. So let's say currently we're not doing anything. I'm not even going to break out of the switch. Okay, I think, can you do a continue inside the switch? It's inside the for loop. I hope so. Yeah, so now if the state was set to backtracking, then we get here, but then we just pass it on to the other one. And then code can be added at this point to filter out cases where find extreme fails. So then we add a test here. In C, no, I'm definitely not talking about C. Although it's the same in C++, so you made a big mistake to ask in C. If you had said in C++, you had a non-zero chance that I would have said, okay. I think you should just Google it. Or ask ChatGPT. Okay, so we did find a local extreme here. That's, I see that on this minimum here, and I see that because of this teal 4-3 polynomial curve that was fitted, which means that the last time we entered, which is probably here, it should have run that new. No, it doesn't. Running this. Okay. No, it did never run the backtracking thing. Maybe you should do one more. Yep. So here it worked. We did jump to the maximum, I guess, of the 4-3 polynomial that was fitted. So we have one at 5.9, and then it says, sorry, yeah, 5.9737, and that next probe is at that position. So then we enter with that value, or re-enter, and then the state was already set to backtracking, because that was set to that where this choice was made, that we jumped to that extreme of the 4-3 polynomial. And then the only thing that we do is you switch back to find extreme. So apparently that works. It just does the same energy check again. So it already did. It seems to have no influence, so that's good. Okay, so then I have to move code from the previous state to the new state. That has to do with detecting that the new sample is not usable for this algorithm. What this algorithm does is it already actually, I guess, initialized 2 cubics. I mean, that just has to happen, okay? So sorry for the scroll, but let's go up to the beginning of this function. Yeah, so we enter here with new samples. And then we get the value of the function and the derivative of the function. Every new sample comes in here. And then in the beginning state is initialization, but of course only the first time, so we can skip that. And then when the state is not finished, so most of the time, actually not even there, here, it's every new point. So current is, I guess, created from, oh, I missed that, we need a current here. So we enter here, and then current is what? Okay, current is just a sample object created from those 3 values that we just got. So the x coordinate, the y coordinate, and the derivative. and that is always inserted in the chain. And the chain exists of samples, and between every two samples, where a sample does an x and a y coordinate and the derivative, and you need only two samples and you can fit a cubic between it. So between every 2 points in the chain we have a cubic. So we insert one here, then we might add one on the end, or we might add one in the middle, in which case we break an existing cubic into 2 parts. And that, since we always insert new samples, we always have to determine what the new cubic is, or the new 2 cubics are that are the result of adding that sample. And that happens here. So if it exists, so if we're not at the beginning or the end, then we add initialize a new cubic. And then we enter this for loop that you saw before. So at that point, the new cubics, if they exist, if we are added a sample that was completely on the edge of the chain, then of course you have only one new cubic. If you added one in the middle, then we have 2 new cubics. Those were already defined. And then the state, I mean this one, the first cubic is also a special state that we only do once. But this one runs for the rest of the time at the moment. That then initializes analyzed cubic objects. So here, for example, so the cubic already exists. Pass that cubic to the initialize of an analyzed cubic object, and then we can call accesses on this object to get stuff like the extremes or the inflection point. That basically means we call the square root, which is the CPU here. So that was a little bit delayed and separated into another object. The only annoying part would be if I need to do this also for the new state, because if then afterwards we decide that we might as well execute this and we fall through, or we go back to the top of the loop and then we execute this state, then it's going to do it again. So this is cubic polynomial, analyze cubic. So this would then be done twice. So that's a square is a multiplication, and then 2 other multiplications. That's 4 multiplications, and a square root. It's probably one clock cycle. Division and another multiplication. So it's not that much, not even a loop or something. So maybe I should just redo it. It makes the code more readable. Anyway, so this state here initializes the or analyzes the cubics if they exist. And then we get to this point, and where if the horizontal direction that we're going into already has been decided, then and only then that special case can happen. So if this is not true, then well, no code that I have to copy or move will exist. So it should all be in this block. So I'm deliberately going to skip over that and then see that indeed everything below this is unrelated to that detection. If it was detected that we can't use it, then right has extreme was set to false. So then this is skipped. So this then is code that has nothing to do with that. So it really starts to think about the two cubics, if there are two, which one to use and stuff like that. But that means that we do consider the cubics to be sane, to be usable by the time we get here. And then, yeah, it picks which cubic is going to be used, so the left one or the right one in this part, which heavily depends on if they exist in the first place. And that if keep going direction here is still equal to undecided, then this special case did not happen. So I can remove this part because I want this state now not to deal with that. So this should always be true, really, at this point in the code. It's still looking at if the cubic that we picked is a cubic that is adjacent to the last extreme that we found. Why is it doing that? Yeah, this is still code. This is still code that I want to remove from here. You see, it might come to the conclusion that this cubic, even though we picked it, is still not going to be used because it deviates so much from the fourth degree polynomial. And I want to do that now in the backtracking state. And then once we get here, there are two possibilities. Either the keep going direction is set to something, well, left or right, so it's not undecided anymore. And then we deviate from the normal algorithm. So this should be removed as well. And then this is the algorithm that I want to keep in this state. So this is also an extreme jump, but this is an extreme of a cubic, not of the fourth degree polynomial. And then only when the cubics do not have an extreme, we can't jump to anything, then we just make a step. Okay, but this is the algorithm that should stay here. I hope. I mean, in my head it's all very fuzzy. like I think that it's like this, but yeah, it's also not, I can't remember all of this, so I'm just wanting to have scrolled over everything till the end, and then meanwhile I just hope that enough is hanging around in my mind until I reach the end. I'm having the feeling though that once we got this low, it's probably all old algorithm that I want to keep anyway. I'm not even sure what it's doing anymore here. I don't think it's related to what I want to move away. So yeah, now forget it. Okay, this is the end. So what did I remember? Not that much, but I think that one of the things is that after doing this, after initializing the analyzed cubics, we have this block here of variables. So we're going to pick which cubic we are used, the left one or the right one. That's being stored in these variables. But we also have these variables. And if this one is changed from undecided away to something else, then we're going to jump to this node, not using cubic, not jumping to an local extreme of cubic, but just jumping to that node. Plus step, left or right, well, depending on this direction, of some relatively small size. But that then has nothing to do with the cubic. This is probably not even defined then. And I want to move that code away. So that means that this should be gone, which means that I might as well assume for the rest of the code that this is always equal to undecided. Which then allows me to scroll again down and then detect which code can probably be removed. So let's say I do know that I do not want to, well, one, detect those situations in which the new sample was sampled too far away from the last local extreme. So far away that a cubic that you fit between the last local extreme and the new sample, it just has no meaning. Let's say the actual function is going up and down and up and down and up and down, and then you sample it again. Well, yeah, you can fit a cubic, but that cubic has 2 local extremes. Well, you just skipped 5 local extremes. So the cubic is just nonsense in that case. That's what I want to detect. So I don't want to add the detection code for that anymore, and I also then don't want to have the code that does, the backtracking. And that is, so backtracking, well, actually I'm not doing backtracking at the moment, but whatever it is, I'm jumping to this point. So this is not necessary, so I'm going to remove it. Because this should not be here. I just know that. I don't want it. I don't want it to be there. But I also don't want to forget about it. So this is line 332, and now we have to go to the other case. You see that we have a billion cases in comments. Okay, let's put that here, and then we can't forget what it does. Maybe use it later. And the funny thing is, now I deleted this variable does not exist anymore, and that's going to really help with finding the code that has to be removed or moved rather, because it's very, very, very likely that that code revolves around these two variables, right? Especially this one. So I'm going to copy this one. Now I'm jump to the top of this case. I'm just going to search for that variable, which I just removed. Okay, now here it's being set to H direction, which means that we just decided ignore the cubic or not use the cubic. But I don't want to do that test even. So this whole block should be gone, including whatever we did to decide that we would enter this block, which is making that true or that true. I think that has everything to do with the fact that I detect that it is adjacent to the last extreme. So you have say, okay, I have 12 viewers at the moment. My experience is that as soon as I really start explaining things, my viewer count drops to 0. Well, not 0, but I'm going to assume that people are really interested, and just words are not saying as much as an image. So I would like to run a program quickly. Well, actually, that's not super clear. Let me first make it a bit bigger so you see more of the function. Yeah, I don't know, 3 extra on both sides. Oh, now we get that. Oh boy, yeah, of course. Can't you do that? Okay, I'll just do git stash. Oh, wait a minute. If I do git stash, then I have to change this again. This is pretty annoying. So I made this that. So is just a test function which has a lot of local extremes, which are pretty noisy in terms of how deep they are. Up, down, up, down, up, 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 down. I forgot what I wanted to explain. Oh yeah, right. So we just find a local extreme. So we have found the local extreme here. And then we do a 4th degree polynomial fit, which is this teal thing here. So we have this thing here, which is very on top of the actual function. So jumping to this point will not be a problem, because that brings us almost immediately to the actual maximum of the function. So if you jump, you know, bang, it's just in one hit finds again a maximum. That was quick. I'm not seeing a 4th degree polynomial being fitted though. That's kind of strange. Well, it's only now. It happens after one more space. Yeah, and this one still fits, but okay. Imagine that the 4th degree polynomial would be ridiculous, and it would be more like this, say, whatever. I don't know how that happens, but sometimes it happens. And then we would jump to a minimum, but a minimum would be here. So you would get a sample somewhere here, say this point here with this derivative. And then we would fit a cubic between this point and that point. Yeah, so you get something like this. Then, of course, this cubic has nothing to do with the actual underlying function. Yes, that's what I wanted to explain. We're going to detect that now in backtracking, as in at the moment we jump to a minimum of the fourth degree polynomial, then we switch to the new state, the backtracking state, which is then going to figure that out. And as soon as I think that the cubic that we fit is again a piece of the real function and a good approximation of the real function, then we can use the other algorithm. So we, for example, now we found this minimum. This minimum is higher than that minimum. Therefore, we want to go now to this minimum and then go to the left. There was already a sample here, so we're not interested in investigating this part here. You're looking for a maximum on the left of 0. And I would say fit a cubic through 0.3 and 0.0. The only cubic that I see is still through, well, points on the right. But okay, I'll just hit space. I don't know. But it seems as worked. Because bang, and it's like hit in one. You immediately found this maximum, so that's good. And then something goes wrong. Okay, this is a good example. So now we fit a fourth degree polynomial through this point and through 0 and through 2 or 3 or something like that. And that does fit, therefore, this minimum and this maximum, but it does not fit this minimum. In fact, the minimum of the fourth degree polynomial is all the way over here, where you see 10 added. So now we have the case where we jump just way too far. And then the cubic that is fitted between 9 and 10 has nothing to do with the real function. And the way I want to detect that is by comparing it with the fourth degree polynomial in the neighborhood of 9. So even though it doesn't give us a good minimum, it is still a good fit around 9, as you can see. So it's only starts to deviate here. So we know that this part here is the correct thing. Yeah, up till here. And with 0.10 we get a cubic that is going upwards. It's like, hello, dude, we were going that way and then you're going up. So it has nothing to do with the real thing. And then we reject it. That's the idea, okay? Now I hope I can recover from my adventure with Stash. I think I have to restore this first. Just have an empty something. So now the git diff is empty. And then we can do git stash apply, push, pop. What is it? No idea, man. Help. No, not drop. Apply sounds good, but I want to also remove it. We're done with it. So I'm going to try pop. Should help work, I think. Git stash pop. To get my changes back. Yep. So it doesn't compile anymore because we removed that one variable. From the top. Yeah, but this here it is being set, which gives me the idea to just remove everything. including adjacent to last extreme, including this. I think the local extreme edge is even related to this whole detection and stuff. So that's probably also not needed. Let's see, so it's set here and then you used there, used there. It's also again used here. But this is also again a detection of, you know, being adjacent to the last extreme and stuff like that. And then used there. So yeah, you can get rid of that as well. And here it's used again, but that is the block where we react to keep going being set, which is not going to be the case anymore. So this thing can be removed as well. Let's move that down to backtracking. And then I want to find where it just came from. Oh, line 337. It's possible to set a marker here. How do you do that? M1? No. I have no clue. I keep forgetting how that works. So this whole block can be gone then, right? All of this. This, and this, and this, which means all of this. I'll just put it here. The local extreme edge is now... Oh, it's still used here as well. Yeah, I mean, still used here, so we can use these variables as well to find the code that must be moved. Yeah, this must be gone. All this must be gone. Keep going directions undecided. Okay, I think it's just this block here. So this plus this, and then everything in it is no longer relevant. Let's remove this. And then that's the only local extreme edge still left, but that's in the block that is doing the step. So this can also be removed, as in this is always going to be false. So I'll just search for the keep going direction next, I suppose. Which means that this can be unindented. Okay, nobody knows where that unindent was. Damn it. Line 418. Thank you very much. 418. There it is. And then this. Let's delete all of this. Move that down. So in this case we probably, that becomes our else then. I think. Okay, so now the variable is no longer used there. Okay, another one. What was another name thing, variable name that we had? Keep going direction. Going to jump to the top. So that is being set here. Oh shit. Yeah, we still need to keep that one. However, this is trying to make a step for a different reason. What is the reason here? Yeah, anyway, we should keep it. Oh, well, no problem. I think that belongs to this. Or does it? I'm not sure now. Okay, well, it seems to still work, because it would be picked up here. Okay, so since apparently the old code was also using those variables, so I'm not sure anymore if I should have moved this here or should have still kept it. Which I guess depends on where it came from. Not to mention that I have to add the variables back then to that scope. Do I save it or do I undo? If I save it, I can use git diff, and if I do undo, I think I'm gonna do undo. I'm gonna do undo and then hopefully find where that part came from, which is now deleted from here. Therefore, it came from here. Line 409. %. What? 18%. 409. already pretty much at the top. Then where's the other code that sets it? Just calling, oh here. Ah, right. Right. Okay, so this is in the block that we unindented. Which means that the other block can definitely be removed, because it's either already set here then, which is then the special case that I'm removing, or it's not set yet, and then we enter this block which stays, which then might still set it, in which case it's going to be handled down below that block. So I'm going to do a redo 409. And we jump to 409. So now it's possible that it's being set here, and then we just still use that one we got here. When we get here. So it should still work, but I need to keep then the variables. These variables must stay defined, so I'm going to copy them back to, let's say, the point of first use, which would be before this block. Possibly 440, but not in the scope. Must be in the same scope as where it's being used below here, which is here, which is the scope with this indentation. So now I'm gonna jump up to before line 440. Just scroll. Okay, so definitely before this scope then. Yeah, so they should be working. This is in the scope of everything. And I'm not sure anymore if the comment is correct. The use cubic isn't set or shouldn't be used. But when is it set? It's being set here. That means we could go to the right so far that it's no longer a cubic. That is, it is just the end of the chain, the last node in the chain. And here it's the other way around. The current is begin, and it's the first node in the chain. I guess that's shouldn't be used. Because I'm not sure. Can we use the set left? It's kind of no, let's only be done if there are no extremes at all. Okay. So that would be, I mean, if this is, if you get here, then this is false, which means that this is not set. So you can do, if use cubic isn't set, then keep going and keep direction will be set. Yep. Do we have now something that compiles? I'm not so sure. Let's, oh, wait a minute. Let's begin with commenting out everything we copied here. That might not compile. No, that compiles. So I just removed a lot of code now. Let's see if we see that back in a way that I say, yeah. So this is finds this minimum here, and then we find this maximum, and then we find this minimum, and then we want to go back. So we jump here to this maximum, and then we find 10. And now I remove the code that rejects point 10 as giving us an unusable cubic. Which means that instead it should just be using it, and I think we just found the maximum, so we want to find the minimum now, and the minimum of this cubic is, I guess, this dotted line. So we're going to jump here. Yep. So, okay, that was then to be expected. 10 is just way too far, and then if we use the cubic, we jump way too far. And now we're going to find this minimum probably, instead of that one. So it must be between these two red arrows. So yes, we're definitely going to end up here. Yep, now it found that one, so it skipped these two. And then I'm surprised, I must say, that we didn't assert immediately, because it kind of should have... It should see now that this is not adjacent to that one. Or am I wrong? I don't know. What's going to happen next? No, it's just ignoring these two. So it's happy with this solution, apparently. So the algorithm now is simply not seeing these minima, and it just says, well, this one is lower than the one on the right and the one on the left. Adjacent, you know, just as if these are not there. And then finishes. So now I have to add that code back inside backtracking. I guess the first test is to just uncomment all the copied code and see if it even compiles. Seems unlikely. Yeah, it doesn't know what the right A cubic is. Yeah, okay. I made it detecting an adjacent cubic. I'm detecting what the adjacent cubic is, and we need an analyzed cubic for the thing as well, I suppose. Let's see where that is being used. I thought it was only used once, actually. Yeah, it's just for the other extreme. Probably needed, I think. Yeah. Either, yeah. Well, I don't like that it's the other extreme, but you know, it's the other. This was used to be a debug function, and I removed the if def around that. So now we can use it as a non-debug function, but it's numerically not as stable as the other one, I think, or I'm not sure. But you can now analyze the cubic for the other extreme, and then we would get a numerically stable thing. So I just the adjacent cubic, and then we do adjacent cubic dot initialize, and then we use the cubic. Well, we don't have that, so we use the cubic, the actual cubic, and then whatever else must be passed. So analyze cubic, initialize, takes a math cubic polynomial, and oh yeah, the extreme type. So concentrates on a single extreme type, and we could use just the opposite. Sorry, opposite of the h direction. H direction, sorry, bullshit. The opposite of the next extreme type. Let me see if that makes sense. Suppose we have this function, up, maximum, down, blah, blah, blah. So like a sine. And we found this maximum here. This is my local extreme. Then I want to, then the adjacent cubic is going to be a cubic that starts in a point around this maximum. And we want to detect if that cubic has a maximum as first thing. In this, so this is the real function, and then the cubic is like that. It also has a maximum. But pretty sure that the next extreme type is already toggled to a minimum, because this one, the maximum was already found. So yeah, so this is a minimum, and then if I take the opposite, that would then be the maximum, and that's what we want to wait. No, so opposite is good here. And then here we can just do the get extreme, if that exists. Okay, so analyze cubic, get extreme, yeah. No, it now compiles. Of course it doesn't. Use of undeclared identifier left has extreme. Yeah, we set that to false here, but that was necessary in order to skip certain code that now is not even a part of this state anymore. We just set this, and then we're going to skip this one. Wait a minute, where am I? This is line that must be in this state. Of course it is in this state. Yeah, definitely. Okay, this is backtracking. So if that gets set here, then this is going to be skipped, because it's already no longer equal to undecided. And this is true, so we just get here, and there is absolutely no reason to set those things. two false. Yep. However, after doing this, I want to change the state back to it's no longer true. Type. Now, normally backtracking means that you jump deliberately, more or less, too far. And then you just start halving, you do a measurement, and then based on that measurement you decide that you stop. Or you just halve the jump distance. So then we halve it again, we halve it again, we halve it again. That would be backtracking, and then of course you would run this state multiple times, and maybe I'll implement it at some point. But right now what I'm doing is nothing. Well, the idea is I'm not doing nothing. This is not good. But the idea is that we jump to the keep going node and then make a step. And that step has the size of, yeah, the code is just not here. I have to copy that. That is a small step. In fact, that step is so small that it can't go wrong. So we're really, if we do that, then we're done with the backtracking. So we don't halve the distance, we just make the distance immediately super small. That's why, yeah, we only run it once. If we do keep here, then, however, keep going is set to H direction. Blah, 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 blah. And then I need to add that code that I think deleted in the meantime. Or maybe, where did it go? I didn't delete anything. What? Keep going, set. Maybe just that jump, the same jump. So this. So I jump to a node and then do a step. We jump to the keep going node. And in the direction of the keep going direction. And the step is just the scale size of the used cubic, which was set here, which is in the last extreme cubic. Okay, that's the other test. So if this one is not set, then I still had another test, which detects if maybe something is wrong. What is that doing again? Oh yeah, that is looking at the angle between. Yeah, it takes a dot product between two vectors, and then basically, based on the angle between them, we decide if we want to ignore it, if we want to set the keep going direction or not. And those two vectors are I hate this kind of comments. While I was working on it, I was like writing many formulas and chatting with ChatGPT and used X1 and XY, X1 and Y1 everywhere. So it was completely obvious what that was, X1 and Y1. I mean, I had a whole mental picture of it. So yeah, I thought I'll just use that, and then it's obvious what it is. But with my 6-year-old's memory, no, I have no idea anymore what this is about. What the hell is X1, Y1? Well, maybe it's described here. Oh, it's described here. Very good. Let's yeah, it's described here. Good. So let's X1, Y1 be the point where the approximation switches from the 4-3 polynomial to the new cubic, aka local extreme edge. Okay, I'm getting it. Yeah, so when I last showed that, we were going to the left, and we had a 4-3 polynomial that was like fitting here and fitting the maximum, and then went down very steeply. And at that I think it was called 0.9 here, is then the leftmost point that was used to fit the 4-3 polynomial. And then 0.9 is also used to fit a cubic together with the 0.10 that was over here. So 0.9 is then this edge point, and the coordinates of 0.9 are then the x1, y1 one. Let px be the 4-3 polynomial and let qx be the cubic. Thus, y coordinates are the same and the derivatives are the same. In that point, in 0.9, say. Now we take the dot product between the vectors from x1, y1 to x2, py and x2, qy, where I guess x2 is the new jump point. Would have been nice if that was described as well. Here's an x2, like literally x2. Yeah. So x1 plus the step. So we have this local extreme, and we just make a step. And then that gives us a new y coordinate for both the cubic and the 4-3 polynomial. And I just draw an arrow of a vector from the local extreme to the cubic at that point and to the 4-3 at that point, and then we measure the angle. Now, understanding that, we can go back to where the error happened here. Cubic is adjacent to last extreme, so that means that the cubic that we have, that we're talking about, is using that last point, 0.9. And yeah, how to check that depends on which direction you go into. So in this picture, we are going to the left. Then it says use cubic is the right a cubic, because the new point is over here, which split then the existing cubic, if it existed, into two cubics. The cubic on the left I can't do that. Cubic on the left and the cubic on the right. So the cubic on the right is the right cubic, and that is then the cubic that is between the new point and the old last extreme that we measured. So if the use cubic is the right cubic, in the case that we go left, and the local extreme edge, which is 0.9, is the next node of the use cubic. So the use cubic is now this point, always the leftmost point, and then next node gives us the rightmost point, and that rightmost point of the cubic must be equal to the local extreme edge. Okay, and our problem here is that we don't have use cubic defined. So it did like the exact same thing. I think this is the exact same thing. So if you go to the left and that left extreme edge, oh sorry, local extreme edge, it's AK.9 equals the right node, which would be the node on the right of the new sample. So yeah, that is the same as the new sample cubic node, whatever, next node. This is just a boolean that we need. So we already have that boolean and we already check it here. I think I can just copy this and move it in the block above. Yeah, pretty sure. So this is just another scope that sets keep going direction. Maybe if it wasn't set already. I want to keep it as a scope, so I'm just going to copy this. And we want to do that if this is true, because that was the same test actually. But this is not set yet. I think this is the only place where I set the keep going direction. The rest is preparing booleans and stuff. So either we set it based on the fact that we definitely skipped in the local direction, or it is approaching the wrong local extreme. And if we don't do that, then we perform this test, which then might set keep going direction as well. And then this is no longer necessary or needed. And then whether or not keep going direction is set is just simply tested here. And still we have a use cubic. Okay, but that's now adjacent cubic. So use cubic is adjacent cubic. Let me look that up again. Adjacent cubic, yeah. Used cubic. That was a wraparound. Backtracking use scope isn't set or shouldn't be used. The comment is also nonsense, no? Having here the expected end of use cubic. Yeah, we already have adjacent cubic. That was just defined. I want to get rid of use cubic, which doesn't even exist in this scope. Now we should see different behavior again, even better than it ever was, because we only execute the backtracking once. Okay, so we find this minimum, this maximum, find this minimum, then we switch back here, we find this maximum, then we want to jump to the minimum of the fourth degree polynomial fit here, which is over here, but this cubic is now, or should be, rejected. I'm not sure if that was already the case. Yeah, running backtracking. So that's 4.10, and then it says not using this cubic, which is correct. Which means that it is going to not jump to the minimum of this cubic, like it did before, but is going to just make a step of the scale of this maximum here. That scale is pretty big though, so I think it's going to end up there. Yep. And before we got in an endless loop because also this cubic was rejected and as not matching the fourth degree polynomial, and then we jump to the exact same spot again, 9 plus that step, so again L11, which is then again rejected, and we didn't make any progress whatsoever. But now, well, we just went back to the state find extreme, and there is no backtracking at all, so there is no rejection, and we just continue with 11. And we find it, and it's higher than that one, so we finish. Ta-da! Fixed. Yeah, no, not really, it is fixed. This seed is fixed. It used to be broken. Next seed. So now we do random curves until we have a problem again. And then we fix that one too. No, that one went correct. So I don't know what I have. I think I'm not really interested in what it does. More like if it crashes or not. Yep, there we go. So this seed is not working. I want to copy the seed for a start. That's a lot of indentation. Too much. Suspiciously too much indentation there. Looks like an unfinished continued somewhere. It must be in the code that I just changed, so I'll just look for it. Quit, yes. Try to reproduce this. Run. Yep, so that reproduced. You see the indentation now is normal. So something is wrong with the indentation, which must have to do with a DC, or rather a continued flag, I think. So here we have continued, continued, or continued, and then a finish. But that is not a problem, even though it's a new code. It's more like a leftover one. So I did remove a finish somewhere. Let's put it that way. Like here. Well, this is just that same code, but I moved. I don't see a problem with it. Nothing. Okay, that's annoying. Maybe it already existed in the previous commit. So let's do a wider search. Continued. If left has extreme, finish or finish. Otherwise, finish or finish. Seems pretty much okay. I would include that here though, just to be sure. So continued, and then we do a finish, or we do a finish, or we do a finish. No, looks okay too then. That finish. Oh, that doesn't look good. Continued, and then no finish. That doesn't look normal. I think this continued should not be here. So that was an old commit. That was a wraparound, I think. Yeah, well, that must be it then. Must have been it. Let's try the random thing again. See if the indentation now stays normal. It's gonna run this. I'll just run it outside. So okay. Good. Oh well. We find another problem, but as you can see, the indentation is now absolutely minimum, so that's good. Could use this seed as well then. Use this seed, why not? It's quite what the hell's happening here? Oh, that might have to do with the flatness here. That is an interesting thing. My functions are defined till 8, and then beyond that point, they're just flat, which confuses my algorithm a lot. But it should work, it should work. Everything should work. So I look into this one or the other one? The other sheet. Let me just remember this sheet. You can remember it for me. Well, I lost the other sheet, of course, because I had it in my mouse buffer, no longer. Well, we have to do this one then. Or try to find another one first that looks more serious. I mean, the flat thing is not super serious. Okay, I deliberately started here. Jeez. There's nothing to do with the flatness, it seems. Or any point beyond 8. No, sure. So the last thing was 6.7, less than 8. Seems to be the same. It's an error related to flat, though. Insanity check. Let's collect a few seats. Yeah, still. And this one is really far away from the flatness here. I think I'm gonna look at this one. How late is it? Oh, it's early. I think I'm going to verwen myself in English. Treat myself a cup of tea. I never drink tea. Instead, I go in many afternoons. I just go for a walk, and I end up in a lunchroom, restaurant thing, and then I have them serve me tea while I read in a chess book or something. Mainly because I'm too lazy to make tea myself. Yeah, okay. 5-minute break. Everyone make tea. I'll be back. Okay. Tea. Now the waiting is for the water. Actually. Everyone studied it. up 7 brings us to the assert. The types must match. Well, they don't, because previous type is left min. It's the left part of a minimum. So minimum, left part, which means going down and then flat. And then get end of that is one of them. I suppose the flat one. I'm guessing the flat side. I'm not sure the false is doing there. Flat low, yep. So that means it's the right side, false. False means the right side. So we had this thing here, ending on flat. And low, because it's a minimum, yeah. The low flat, totally. And the new node has as type up. That's not correct. That should have been the right side of a minimum, aka right min. Now, where exactly is that? Node is 17. So apparently 17, or well, every point is here it seems, but this. So this one was detected as being a minimum on one side, but it's not detected as the minimum from the other side. It's just going up. Well, I'm going to begin with zooming in, I think. How about we run, well, I don't know, let's print it. That is 4 point something. And how far do we zoom in? A tenth. Plus or minus at 1/10 should do. And I do not have the seed yet. Let's copy the seed as well. This is the seed, and holy moly! Okay, yep, stop. That's oh man. That's what happens when my mouse wheel was rolling and then I came on the desktop. And then it switches between two desktops. I hope nobody was watching who gets triggered by that. Down, down, down. Okay, I wanted to copy this. Ah, you see, epilepsy all over. Viewer count dropped like a rock. But hey, they are not able to unsubscribe anymore. I'm just kidding. So, quit. Edit. Edit, create test. Let's not restore. I want to edit it. Create test, and now we do something like it's nice 10th. Well, maybe even less than a 10th, because it was already there. This water is considerably warmer than you get in a cafe or restaurant. I think that's in a cafe it's 70 degrees. Or it should be 70 degrees. Celsius, of course. And this water is 100. Well, not 95. It already stopped boiling. So yeah, I should figure out how much cold water I should add after it boils, so I get it right immediately afterwards. I have no idea why or what. I think I just have to pull this. Okay, that worked. Sink. This tea bag has absolutely no intention to sink in the water. I have survived for 5 years or 10 years, it says. I'm not going to be... Okay, what did I do? It's going down. Yeah, yes, it's submerged. We succeeded. Okay. That was the seed, I hope. Holy zoom in. No. And of course, everything what happens now is outside of this. We are 15, 16, 17. Still can't really see. Well, I guess 17 is on the right of the actual minimum because this is classified as up. And I would have to zoom in like crazy. I could just zoom in till plus or minus 100th, I guess, and then maybe you can see it. But I believe it. I can just look at the derivative in 17, of course. 17, where are you? There it is, 17. Derivative is positive. Like bang positive, 0.1. Yeah, so it's on the... Yeah, like it says here, it's just going up. And then where exactly are we marking something as a left min? That must be after the next point is added. We already have that, 18. 18 type max. No, not really. Have to zoom out again. Otherwise I don't know which point is on the left of 17. Oh, I can see that here, of course. 17. So 18 is on the left. Yeah, I am not printing the types here. Would it be nice to do that? Either that and or print when we mark something as a flat type. I'm not seeing a flat type anywhere. Up, left min. Here's a left min type. Result. Initialized cubic between 17 and 18. Yep, so 18 is on the left of 17, somewhere on the left. And it detects that this is flat in the end. So horizontal. I mean, I say flat, but it's before because it is 4 characters, and I use horizontal already somewhere else. Yeah, now see, now my tea is too hot. I want to start drinking it now. It definitely would burn my lips. I'm going to add cold water. Oh, I have a tap right here. I'm so lazy. I even have water on my desk. So yeah, I know how it sounds, but is it now drinkable? That is the question. I think it's still too hot. There wasn't enough room in the cup to add enough cold water. It's doable. Yeah. Okay. So it seems that this is directly detected as being left min. During the call to initialize cubic. Why? That must be because the derivative is like 0 there. So we should put a breakpoint here. I don't know where it does restart. And just set a breakpoint. Break. I think it will restart the dot here, so that is above that point anyway. Alright, we get first this one, and then I have to skip one, and then we get the second one. So we do a rerun. And putting backtracking. Tab up. Tab left min. Nope. Went too far. Rerun 44. It's one less than 45. That seems to have worked because now we don't see it. So now I can do continue, and then we do break in that breakpoint, and then I do continue again because we needed the second one. And now we print. Well, that was the previous one. No, this is the new one, sorry. Now it's going to determine that type, and it does it as follows. Assert, initialize the cubic. The current object, this label 18 was the last symbol that was added. Yes, it was. 18 was just added. Then the cubic is on the right of the last symbol. We use a different color than it, otherwise assume next was the last. But this should be true. And therefore we are going to use the side equals right. But that's only for the color. So we get this color. This color. This thing was just drawn when I hit the return there. And then we do significant derivative. Aha, so we have a derivative estimate here, and we're going to multiply that with this, which is very small. And what would my derivative scale estimate be? Step That is the scale estimate divided by the LW scale estimate divided by the W scale estimate. Right. The LW scale estimate is calculate. As if it is cheap. Clock cycles don't cost anything. Square root. Average absolute derivative. Okay, as long as it's not zero, I believe it. But definitely not zero. Yeah, we have a huge derivative there. I'm very happy with it. Finish. And then the W estimate definitely should be correct. Should make sense. Yeah, this is just going to be okay. Do finish and it prints it. So 0.29. I don't know what it is. 0.9. That's the distance between 18 and 17. Can you imagine how much we zoomed in? I'm from the Netherlands. Can't you hear that? Can't you hear that? I'm from the Netherlands. I am from the Netherlands. Okay, I'm really trying not to have an accent, but sometimes my boeren nature komt services, yes. I'm just kidding. So, that's going to return something even bigger because we multiply it by 5. You got 10,000-ish, 15,000. Wow. Okay, I'm happy. Wait, where are we now? Nobody knows. Oh yeah, and then we multiply it by that. Let's do it next. So then the significant derivative is 0.15. That's really, really small. Still. So apparently the derivative in the current point, no, in the next point. So this one is definitely not 0. This one is huge. This is 0.18, right? Yeah. Yeah. In 0.18 the slope is super negative. You're going down. So 0.18 was 0.15 or something to the left of this point. So I don't know. 0.15 here. And then the derivative here is pretty small apparently. Next, so this sign is -1. And the derivative of next is, yeah, very small. Smaller than what is significant. That is why we detect that this must be a minimum, because the derivative is really, really, really small, like 100,000th of something that you see in the neighborhood here. And we really did calculate it, as you can see. Schussel, I mean, with all the stuff going on here. Now, I can't disagree. It's like totally horizontal here, right? However, it's already green. This is already detected as being a minimum. Which means I might as well set it to flat anyway, even if it is not detected. But I think I'm only doing that when... Well, no, it's not true that the point itself could be a little bit here. Say the 0.17 could be here and then still be marked as a local extreme cubic. And then you have to actually do a calculation to find the minimum of that cubic, which is then the local extreme. But now the point itself is in the local extreme, only at least so close that the derivative in 17 is almost 0. Okay, what to do? 17, 17, 17, 17. Oh, okay, I get it. 18 is the first point on the left of 17. So there was no cubic on this side at all. Now we add 18, therefore this cubic exists for the first time. And it ends on a horizontal part. Yeah. While, strangely enough, that was not the case for the derivative between 17 and 16, but that's probably because 16 is super close to 17. If you would zoom in even further, so you can only see 17 and 16, then on that scale it is not horizontal anymore. That's why it was not marked as flat, because then the scale was just, you know, super small as well. Once we mark something as a local extreme and we mark it as flat, then we want it to be flat on both sides. So now I have to fix that for the cubic between 17 and 16 and make it flat on the side of 17. Well, not really, but my sanity check wants that, so maybe I should. Now I'm thinking about where in the code I should detect that. I think I should detect it immediately after initializing this cubic. And yeah, I'm calling initialize on a cubic, which results in a flat type. Okay, let's have a look at the code. I'm pretty sure I'm doing it elsewhere also. So I would like to remember or find back the name of the function that does that. How would I have called that? Change, I think. GSX. Change something? Change underscore. Change type to left extreme. Yep. Does the thing come with the comment? I doubt it. Nope. Okay, so we had an up and we need to change the up into this. That's a right min. But that's the output, huh? So up. Input up, output. Oh, this is not the one. I need to call this one, I guess. Yeah, so up is changed into right min. Whoops. So on node 17, I need to call this function with a minimum as extreme type. And then it will fix up into right min, which is what we want. So go look for code that already calls this function, because it doesn't exist for nothing. Well, it's only here. But we should be in the neighborhood. Left side is flat. Now what is this testing? If the left side is flat and the right side is not flat, we call this. Now where do we do this? Directly after calling initialize node. Done. So we have this. What the hell is initialize node again? Initialize node calls initialize cubic. Yeah, okay. So that is basically after initializing that cubic. And then we call the right function for the right node. So there must be a left node, I guess. A left node, which... No, not really. Initialize node. There must be another initialized node. Also not really. Seriously, dude. Yeah, here it is, I think. Or not. No, it's just here. Apparently we only call this one or that one. And it's called on the new node or on the left node. Yeah, and then suddenly the tea is cold. Time flies. The left side is flat. Okay, I'm calling it on new node or left node. I have a nice picture here. New node is the minimum. Left node seems to be pointing to the cubic here. Left node, new node cubic. Oh yeah, of course, we call it on... It's the type of a cubic, so it's not really the nodes in it, but more the cubic. So this cubic here is stored in this node, and this cubic here is stored in this node. And then we check for new node if it is flat on one side, I think. So is the right part of the left node new node cubic? It's this one. And then the right part of that. Is that flat? Test. And we also test if the left part of the new node right cubic is flat. This part. And then we did the blah blah blah, and then if that doesn't fit, then we make it fit. However, that means that we only check around new node, while what we just had was that we added this point 18, and that was the new node. So now this is new node, and this is right node, and the problem was that now suddenly this part became flat while the other side wasn't. So we have to do the same kind of check for, unfortunately, the other end. So if you move that then back to this case, I have to check if this is flat and that is flat. And then compare it with that and that one. Oh my god. Triple the code. Okay, I think I'm going to stop because it's kind of a cool time to go to bed. And my viewers dropped to 1. Hello, last viewer. Do you like to see a game of chess before I go to bed? Yeah, I have to. Okay, I might as well keep this window open as a reminder for tomorrow. Lie chess or lichess? How do you pronounce that? For best by. Attack the pawn. Okay. Attack the knight. Okay, just castle. Can't take the pawn because. I don't. Is this good? Normally, well, you know, if you know opening theory, if I would have taken the attack with this pawn, and then if I take that one, the queen comes here, attacking the knight and this pawn, so I lose. I can move the knight back, but then the queen takes the pawn. Oh, it was not possible, even though after moving the knight, attacking my pawn like that, I just castle, because if they take it, I attack the knight and then chase it away and take here. In other words, I'm thinking about taking here, even if they take back like that, and I take here, and the queen comes here, and I go back, attacking the queen. They would have to take with the queen, and then I can put my rook here, which does not win a queen because the bishop is over there. I can just take immediately. Nope. I think I just have to defend my own pawn first. No, I probably could already have done it. Just take the knight and then win this pawn. Now the thing is defended and all. I think a whole minute away, and then the next move I have the opportunity, I'm still not doing it. That's so stupid. I'm stupid. Yes, thank you for letting me exchange my super bad bishop. That's also a movie. Super bad. Let's go here. I think this threatens something. Okay, I'm a complete idiot. That was not what I wanted. Move the king to the side, so it comes as a surprise when I move my knight, and then suddenly... Okay, what is this? I just go here, and then what are you going to do, man? What are you going to do? Except nothing. 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 Okay, bishop comes here, but then I play my rook here. All is good. Is there a problem? I don't think so. Just, take, take, take. Threaten mate. No, not really, because it defends like that. But I lost a pawn. I don't want to lose a pawn, so I'm going to do this. Right, right. I think so. It's not working. Fuck, it's not working. I can't take back. Oh, I can take back, actually. No, I cannot take back. Yes, I can take back. Okay, they cannot take it. They take it, I take, and I thought this was maybe mate, but I just put the rook back. And then nothing. No problemo. What are they doing? Get a free open file. Okay, maybe not. Instead, I give away bishop. Wait a minute. But we can save the day. Take my bishop. Ha ha ha. I'm still losing a pawn though. I lost a pawn. Let's put the bishop where it counts, or yeah. But then this bad bishop comes here, and then what do I have? Absolutely nothing. It does not make me happy. I can go here, but he exchanges it anyway. But okay, exchange, here, and then I push, take, look good. I'm gonna do that. This rook's not doing anything. The rook that is not doing anything. Yeah, I thought so. I predicted it. You lose. Predicted it. And now I have a beautiful free pawn, which is being attacked by two rooks, but can defend it. That is slightly annoying. I definitely can't go up. He just keeps pushing it. I'm gonna go here. Maybe I should not do that. Let it advance one further. Put this rook in between and then use my king to attack it. Which means that then I want to be able to put my rook there against a check. Yeah. Yeah. Oh no, I'm losing this pawn. Okay, there's too many pawns. Way too many pawns, and totally on the wrong square as well. This everything. This is where you have to go here, but it's not possible. So what do I do? This first, maybe. Yeah, now I can go here. And then we win at least one pawn back. But yeah, not a good thing. Absolutely not a good thing. Is there anything I can do here to not lose? I don't think so. Maybe doing nothing. Doing nothing is gonna make him promote, I think. Let's walk to the center for now. It's pretty much lost. Okay, we go further to the center. And then I'm going to give check maybe. And then attack the rook. Well, can't attack the rook like that, man. Okay, but now you can't move the rook. I can still move the king though. Or not. Okay, now I can attack the rook. But so I can't move the pawn, I can't move the rook because I don't know. Or then I take the pawn, and I can't move the pawn because I take the rook. But he can still move that thing and then move the king. Shit. Sucks to be me. Okay, let's do this. You can have it. Take it. Shit, he doesn't want it. I'm not happy. Okay, got this. Yeah, why not? The why not move. Okay, this now I lost. I said I already lost before, but let's do a rematch because come on. How am I going to sleep like this? Does not want a rematch. New point. Oh, that was bad. I don't know where I went wrong, but probably on the second move. Okay. It's my move. Oh, sorry. Well, oh. Move. Okay. Check something, defend it, develop. What is wrong with development? Nothing. Yeah. Suppose I just go back. Let's not allow that pin. Can't be a good move. Definitely is not a good move. But he's allowing it. Yeah, true. I can take it. But yeah. What about the queen here defending the bishop? Could you put it one back maybe? One back. Gives me open H file, A file even. Cause And then we have to make use of that open file. I need to defend this bishop at this pawn here too. Let's try it like this. Indirectly defend it. Maybe just push my double pawn. Why not? Seems like a good idea actually. Oh, I gave it away. I gave the pawn away. No! I hate that so much. Why am I doing such bad moves? This is no fun. It's stupid. Horribly stupid moves. I'm gonna win on time. Watch me win on time. Okay, I'm gonna do this because I wanted to. Maybe I should have pushed it too. Now I think about it. No, well then I could have pushed it again. Maybe. No, it's just horrible. It is horrible. The only little thing that I have is that he can't push this pawn. I have to keep it that way. Can put the rook here. Block it. I have to really chase this one away. Or maybe exchange it against this knight that is not doing anything. So go here, take. It is a possibility. It is a possibility. No, queen here. Take it indirectly. And then maybe push this pawn. King side attack. Seems that this guy can't make any progress unless he moves the knight. The knight has to go back here. Not sure what he's trying to do. The knight is defended now though. That is true. Great, he's going back. Free pawn, okay, so I take here, and if he takes, I take there, and if he takes, I take here. And then I have my pawn back. It's, I think, is that worth it? Let's see, so I take, I lose, no, I do not lose this pawn. Take, I take here. If he takes there, I just take here a check, and then I win the piece here as well. I think I just win the pawn. Well, a pawn is a pawn. I mean, I'm pawn down. Let's just take the pawn. But the only thing high here is my puzzle rating, so I have to make use of that. Make use of tactics. Now he wants a queen exchange. I'm not sure that is a wise decision. Because he still has a really, really bad bishop. I think I just do this. Develop my knight. And then defend the pawn and block this pawn again. Well, I can push it, but then I just take it. Yep. And now we push this pawn or this pawn. Guess this pawn because I have the black bishop, so I put the pawns on white. Okay, so if he pushes and I take, he takes, I take, so he threatens to take now, definitely threatens to take. And if I do this, take, push, take, that would be a pawn. So let's do this. Yes. Now we can make a free pawn, or yeah, why not? Or maybe this is a weak pawn, that is the question. I could go here and then attack it. It's a bit difficult for this guy to defend it. So I do this. Can't stop me from doing that. The knight can never defend it. If he pushes it, I just take it. Unless this is pushed. And then I take, he takes. He defends that point, but I can come back. I think I'm going to try that. Just win this pawn instead of exchanging it. So. Now it's too late to push, right? No, it's not too late to push. So he threatens to win this then. I have to take it back. So he does this, I take, yep, I take, he takes. And then I take here. This was too late. So now we have a double free. Okay, let's exchange that. Thank you very much. Double free pawns. That is brilliant. So we run fast or slow? I'm gonna run fast. My king has to go to the center. That is very clear. Okay. Stop this pawn from advancing somehow. We'll go here. Yeah, well, I don't have much options, I think. So attacking this one, but I can just push it. And then everything is defended again. I can now put my knight here and the king here. Everything is totally defended. Totally defended. I still can do this, I think. Then the knight can escape to here, but no, not really. Go check. Win this pawn. Threatening to go here, and then he can give check and just go there. Is that a problem? Not really. Also, not, now I can win this pawn? No, not really. Well, let's first go here. And then go there, like I said. Now I'm threatening to win this pawn. with this fork. Yeah, I just have to promote. You gotta be kidding me, man. That's impossible. You can't exchange a knight. I want to have this one. Nah. Fuck that. No way. Oh, wait. Oh, wait. 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 No. Wait. Fuck. Yeah, that's a rule. Well, that was not smart of me, was it? That was definitely not smart of me. Yeah. Can I still win this, is the question. I have to stay here and this king has to stay there, so I think I can still win it. Oh man, that was so well played. Really? No, what? Yeah? No. Wait. No? I'm not so sure. I can still do this, right? I do all this. He takes like this, I have a free pawn, I win. He takes like this, I take that one, I stop that one, it's just a win. Ha ha, I still have one. Oh, it's an exciting game. I can stop both pawns, yep. Can stop both pawns. Well, you can take en passant like that. No, I can't move a pawn. No, this is lost. This guy is totally losing. Yep, like that. Resign. Sid, yeah, you can play against me if you were on light chess and challenged me and stuff. But I play chess because I have to go to bed, so. Are you already logged in? Because I want to go to bed, really, I just want to go to bed, really. Still no challenge, see? It's just, yeah. If we do this, it's gonna be 11 o'clock before, okay, you were there. This is you, I suppose? Oh my god, you have a rating of 2254. I might as well resign instantly. Nobody can win against that. I lose. Well, you can teach me actually. If I make him, if I do stupid things, then tell me about it. Let's put this one outside my pawn chain. That's what I was thinking. And then we have to develop stuff like develop this one. And develop this one, and yeah, where should this one go? Here, that's a bit weak, but yeah, probably not that bad even. Not even that bad. Oh, it's my turn. I missed that. So you did a check. You know, you move the pawn. Do you want to have the bishop there? Well, okay, go ahead. You want to have my bishop. Towards the center anyway. It's not like the rook is doing anything there, is it? It's not really doing anything. Not really doing anything. That rook was useless anyway. Just standing there on that open file, half open line, I mean. So yeah, I decided to get rid of it. Going back. Strangely enough, he's going back. Oh. Oops. Well, yeah, no, it's definitely an oops. Can I do a take back? No, I don't do take backs. I'll just resign and then go to bed. There. Duh. Huh? Why do you not take my bishop? Pretty sure that was winning. Oh, wait a minute, then I lock up my knight. That's not funny. Yeah, it sucks, but I don't see any other possibility there. Nothing to see. Now we want to exchange suddenly. Nasty. I do not want to exchange. I do not want to exchange. I repeat, I do not want to exchange. Oh shit, he's attacking my knight. Don't attack the knight. It's a very nice knight. The knight did never do anything to you. Yeah, I'll let you take my... Oh, this knight is still here. Well, okay. You'll have to wait a second, I guess. It's not even threatening anything. Damn it. Why am I not using my other rook? I should be using the other rook. I'm gonna use the other rook. It's kind of difficult. Trying to exchange again. Okay. Yeah. Oh no. Yeah, that was not good. That was not good at all. I don't know, did you know? All my pawns are gone, probably. No more pawns left. Can't give away my knight. Shit. Yeah, you win. Well, good game, but yeah, your rating is like wait, like never win from 2000 even, like 2050. It's never. It was, nah. Okay, you do make me wonder though where I made the mistakes and stuff. So white is better. It's equal, totally equal, still equal. Black is better. Okay, this is where I go to bed. What was the best move here? Go there. I don't know why. I mean, if I go there, then yeah, you just chase it away, say, and then I go there, and then okay, then I don't have to exchange it because this is too weak. This is a bad move. Hardly. My God. Okay, I can check that thing. Yeah. This is completely over my head. I don't understand stuff like that. So I just think, well, I don't want this, and I'll just stick towards the center. That was at least the best move. Yeah, that was not a good move, apparently. Yeah, I should check. I took on a pawn. Okay, probably not much change. Oh, double question mark. What is happening here? You did give the check. +2. I think you missed something because I don't think you... Yeah, still +2. Again a double question mark. Yeah, but you didn't punish it. You didn't punish it well enough. You should have gone forward here. I was surprised when you did not do that, because if you go forward and I take it, you just take the knight back, and then I sacrifice the rook for nothing. See, that is a question mark, but it's still +2. No, you could open the center. You could have opened the center. Yeah, totally. It's the 2 against 2. And now I should have taken the bishop here. So I said, oh, let me do a take back. Because if I take here, you just should take my bishop. That was not 2200, man. Yeah, +5. There's only one move possible, dude. Double question mark. What does he do? Double question mark back. No, it was pure tactics. And I said it over the mic. That it was a horrible move. Do this take here. No, I did do the bishop. Again, a horrible move. +3. I have the feeling at some point it became a draw again. Or am I mistaken? Yeah, that you see that queen exchange is not too bad. I mean, this is the computer move, but queen exchange is not making it a draw. Still +3. That's also something I don't understand. How can you see that? Why is it good for white here to exchange queens? Yeah, you can open the center again. Seems to be the best move. You up the exchange. But I have 2 pawns. It's 4 against 2 pawns and an exchange. So in material, we are not totally unequal. Okay, it's a double pawn. That is true. But if I can keep this a backwards pawn, because you just don't push it, you keep not pushing it. Should have pushed it again here, but this is horrible. Now you're back at plus 1.5. It's still better than me though. I went to the wrong square for some reason. Plus 2. No, I could still go back. I probably made a very big mistake very soon again. Oh no, I did exchange it. Yeah, because isolate double pawn. I mean, come on. I mean, yeah, okay. Then I want it. And the question, I have no idea why you're plus 3 here. I mean, if you just count it. This is 13 points, 14, 15, 16, 17, 18, 19, yes? And I have 11, 12, 13, 14, 15, 16, 17, 18. Okay, 1 pawn down. But you have an isolated double pawn and a backwards pawn. So why the hell are you plus 3? So if you count, what is it, Euler, no, who made these points, the 3, 3, 5 points and stuff? It's more or less equal, but you say in an end game, those rooks are just much stronger than your knights. Okay, well, that's over my head. Yeah, I wouldn't know why and stuff. No idea. But I guess it's true. Oh, that was a bad move. You did a bad move. Now it's only that 1 pawn. So yeah, I mean that's what I mean. Like, this is plus 3. Why is it plus 3? And then what you say still holds after the move that you did. But now it's just that 1 pawn. Hardly. Apparently you're not creating enough open files. You should maybe still have pushed this pawn. What is the right move here? Yeah, put the rook behind it and then push this pawn. Probably. Let's say I still move this, the computer move, and now you can push the pawn. That's the way to go. Make open files, but you didn't. You did that. And now black is better. I had this feeling, yeah. At some point it was a draw again. No, it's minus 1. Wow, I should have won this. Get my pawn back. You don't have any open file. No, not the best moves, but I'll just blunder it away. Yeah, there it is. There it goes. What the fuck? I mean, I have no clue what to do in a position like this. I'm 100% a noob. I have no idea what to do. I have no plan. There's just literally no plan in my head whatsoever. What is the plan in this position? Yeah, I shouldn't have changed the rook. I mean, why? I mean, why is black a little bit better? So there must be a plan. What is the plan of black here? Do nothing? Or definitely not exchange rooks, okay? But I'm just gonna do what the computer says and then see what happens. Maybe then a plan will be revealed. Push the pawn forward. Oh, king comes forward. The knight retreats completely. You just give this pawn away, yes, and then the knight Oh, so the pawn is played so we can put the knight here, which attacks this backwards pawn. Oh, no, I win it back because you can't do this. No, you can't do that. Aha, okay. And then I take it. Yeah. So I get my double pawn against the backwards pawn? No. Still not... Kind of keep it close like this, of course. Now my pawn structure and my knight are much better than they were. That is definitely the case. King to the center. Okay, it's 11 o'clock. Minus 0.4. You see the minus here? That's where we quit the stream. Black is ahead. Black is winning. Who's black? Oh, that's me. That's. Don't look at this. Don't look at that. No, seriously, I have to go to bed. Thanks for the game and good night. Maybe another time you can teach me chess.